Hey guys, welcome back to part 2 of the IGCSE Integration 2024 topical questions. So let's get started. Okay, first question. It is given that this equation for x is larger than 0. Find the differentiation of this equation and then give your answer in this form, where a and b are integers. Okay, so this question involves the quotient rule because this part is a fraction. Okay, so to differentiate this, you make the numerator as u, and u is equals to ln 3x, as I did here. And then the denominator is b, and b is equals to x squared. Differentiating ln 3x will give you 1 over 3x, and you need to multiply 1 over 3x by the differentiation of 3x, which will be 3. So when you simplify that, it will be 1 over x. Okay, and then you differentiate v equals x squared, which will give you 2x. And then now you can use this equation, which is the quotient rule equation. You sub all the values from this part into the equation. And then you should simplify to get this final answer. And this answer will be in the form of this, because that's what the question wants. Okay, part B of the question, hence find the integration of this. Okay, so since the question has hence, you should know that it's a continuation of part A of the question. Okay, so we can use part A to help us answer this question. From part A, we know that when you differentiate ln 3x over x squared, you will get this. So integrating this part will get you ln 3x over x squared. Okay, so in this line, I wrote integrating 1 minus 2 ln 3x over x cubed will give you ln 3x over x squared. I just separated these two parts. Okay, so using this line, I'm trying to get integration of ln 3x over x cubed dx. And to do that, I will separate this and this. And then I'll move this part to one side. Okay, so I'll move this part to one side because this has integration of ln 3x over x cubed dx, which is what we want. Okay, now we will be here, and there's a 2 in front. So I'll move 2 to the other side. So you multiply the other side by a half. And now you have this integration of ln 3x over x cubed dx. And then you just simplify this part. And this will be the final answer. You need to remember to add plus c, which is the constant. Okay, so part B, I. Differentiate y equals 10 bracket x minus root x with respect to x. Okay, so when doing this, I will simplify the root x to make it in the index form. So it's x to the power of a half. And then I'll differentiate that. So differentiation of 10 is, differentiation of 10x is equal to secant squared x. So differentiation of 10x minus x to the power of half will be secant squared x minus x to the power of half, which is what I did here. And then when you differentiate, you need to remember to multiply by the differentiation of this, the values inside. Okay, so differentiation of x minus x to the power of a half, this is equals to 1 minus half x minus to the power of minus half. So this part, you need to multiply this part by secant squared x, this part. So yeah. So this is the final answer. Okay. Part 2 is hence find the integration of this. Okay, once again, the question has the word hence, so you need to use part 1 of the question to help you find the answer. Okay, so from part 1 of the question, we know that differentiating tan x minus root x will get you this. So you have to try and simplify this part to make it equal to this. Okay, so the way I did this was for secant square x minus x to the power of half, we know that secant square x is equal to 1 over cos square x. So I just changed secant square x minus x to the power of half to 1 over cos square x minus root x. And then that is multiplied by 1 minus half x to the power of negative half. Okay, so that gets us this part of the working. And then we know that from this part of the question that there's actually root x in the form that we need to get to. So I will change minus half on the power to a root x so that I can get in that form, you know. So changing x to a power of negative half will give you 1 over root x. So that's why I multiplied by 1 over root x here. Okay, and then simplify the equation. And since the numerator has a fraction, I want to try to get rid of the fraction. So to get rid of the fraction, I will multiply by 2 root x, and doing so will give you this. Okay, so now we have the format from the equation, and we know that differentiating this will give you this. Therefore, integrating this part will give you tan x minus root x. Okay, so this is what I wrote here. Okay, so the only difference between this part and the one in the question is that there's a 2 in the denominator. So to get rid of the 2, you can take out a half, and we will have the format in the equation. So when you get rid of a half, you just multiply the right hand side by 2, and then you need to remember to add the constant. And yeah, this will be the final answer. Okay, next question. Find the exact area of the region enclosed by the curve y equals e to the power of 2 minus 4x, the x-axis, and the line x equals to minus 0.25, and then the line x equals to 0.5. Okay, so there's a lot of lines and curves here, but to make it simpler to see, I suggest you guys to draw the graph, which is what I did here. Okay, so I have the y and x-axis, and then I drew the exponential graph, and then the line, both of the lines actually, yeah. And now you can actually kind of see what the area what is the area that you need to find. Okay, so the area will be this part. Okay, so this is actually not too hard. You just need to integrate the exponential curve between 0.5 and minus 0.25. And doing so will give you the area between all of these points. Because integration of the exponential graph will give you any point that is below the exponential curve. And since we want to find the area enclosed by both of the lines and the x-axis as well. So it has to be above the x-axis and between minus 0.25 and 0.5. So it will obviously be this. Okay, so now is the straightforward part. You just integrate the exponential curve, and we know that integration of e2 minus 4x will give you the same thing, but you just need to remember to divide by the differentiation of this part, which will be minus 4. So that's what I did here. And then you just sub in 0.5 and minus 0.25 into this part. You sub it into this part again, and in the end you should get this, and you do not need to add a constant for this. Okay, last question. Find integration of this, giving your answer in the exact form. Okay, so this is relatively straightforward. You just add 1 to the power because it's integration. So you add 1, and then when you integrate, you need to divide by the power, the new power, so it's this, and then multiply the denominator by the differentiation of this value, so it will be 5. So yeah, multiplied. And then we will simplify this part a bit. So the new power is 1/3, and yeah, you simplify further. Okay, now you can sub in 4 and 2 into the equation, and in the end you need to give your answer in the exact form. So you need to leave your answer in the most simplified version, which will be this. Okay, so part B, find integration of this, giving your answer in the form a plus ln b, where a and b are integers. Okay, so integrating this equation, let's do it step by step. Okay, so integrating 4 over 2x plus 1 will give you 4 ln 2x plus 1 over 2. And that's because the denominator is a linear equation. It doesn't have squares or like any powers in the x. So that will give you 4 ln 2x plus 1. And then when you integrate, you need to divide by the differentiation of this part inside the ln. So it will be 2. And for the second part, there's a squared inside the denominator, so you can rewrite this part of the equation as this. And when you integrate this, you just add 1 to the power. So minus 2 plus 1 is minus 1. So it will be a 2x plus 1 to the power of negative 1. And then you divide this by the power minus 1. And you multiply the denominator by the differentiation of 2x plus 1, which will be 2. So you simplify this in the next line. And this is what you should get. And once again, you just sub in half and 0 into the equation, and you need to leave the answer in this form. So you will be getting 2 plus ln 4 as the final answer. Okay, so that's it for this video. It's a very short video, and if you have any other topics that you would like to see the past year papers for, feel free to leave them in the comments. Thank you!